welcome to physics class. This is Mom Chen and we are going to discuss about 3 topics for today. These are the acceleration, constant acceleration, and free fall acceleration. What is acceleration? What do each of these short clips have in common? Yes, they are all examples of acceleration. Acceleration is the rate at which velocity changes. This change can be a change in speed, direction, or both. An increase in acceleration is positive acceleration, and a decrease in acceleration is a deceleration. You can find the average of the acceleration by taking the final velocity minus the starting velocity divided by the time it takes to change the velocity. Let's work an example. A person walking starts at 0 meter per second and after 6 seconds is traveling at 5 meter per second. What is the acceleration of the walker? Final velocity of 5 minus the initial velocity of 0 divided by the number 6, which is the time. You get 0.83 meter per second squared. Let's take another example. A car speeds up from 22 meter per second to 26 meter per second in 2 seconds. What is the average acceleration of the car? You'll take 26 minus 22 divided by 2, which is 4 divided by 2. We get 2 meter per second squared east. So there we go, it is the acceleration. Let us now proceed to the constant acceleration. An object is accelerating if it is changing its velocity. When the velocity is changing by a constant amount each second, it is referred as the constant acceleration. We have here a graph. The horizontal one means the time per second and the vertical one is the velocity meter per second. This example shows the constant acceleration. Race. Both of the moving cars are moving in a constant acceleration. Let us now proceed to free fall acceleration. Whenever you drop a stone in a third-floor building, it falls straight to the ground. This is an example of a free fall motion. Whenever object falls to the ground, we can say that the object is in free fall. This is caused by the gravitational force. Initially, you are holding a stone and you can say that the stone is at rest. Hence, the initial velocity of the stone is equal to 0 meter per second and the initial time is 0 second. When you let go of the stone and right before the stone hit the ground, the stone now possesses its final velocity, the time it takes to travel. Traveling the distance from the third floor to the ground. Again, at first, the velocity of the stone is 0 meter per second, and right before it hits the ground, it possesses the value of velocity. We can simply say that the stone is accelerating. In free fall, the free-falling objects accelerates towards Earth, and this acceleration is due to the gravitational force of the Earth, which is denoted by small letter g using few mathematical equation which is derived from the equation of g as g is the universal gravitational constant which is equal to, and the m is the mass of Earth which is equal to, and the capital letter r is the radius of the Earth which is equal to. So substituting the known value, we can get the value of small letter g, which is equal to 9.8 meter per second squared. Do you know what is interesting? This value of g is not dependent of the object's mass. From the equation, it is dependent only into the mass of the Earth and the radius of the Earth. It has nothing to do with the size or mass of the object. Why is this interesting? Now let me give you an example. Suppose you're standing, you are holding on your left hand a stone, and in your right hand a paper. You drop them together in the same height. The question is, which object reaches the ground first? Yes, you're right. It's the stone. But how about if you crumple and squeeze the paper and drop them together at the same height? The question is, which object reaches the ground first? Well, the answer is both of them reaches the ground at the same time. Because again, what governs a free fall object is the gravitational acceleration, which is constant and is not dependent on the object's mass. In our previous example, the reason why the paper falls behind the stone, it is because of the air resistance. If we eliminate the air resistance, then the stone and the paper will fall at the same time. I hope you have learned a lot. Thanks for watching.